Well, hey, everybody. Welcome to another episode of Electrician Live. My name is Paul Abernathy, your host as always. I want to welcome you to the podcast where we're going to have another episode that hopefully will be informative. You'll learn something from it. You'll share it with other people. Remember, we're available on, what is it now? Deezer, iHeartRadio, Spotify, Apple Tunes, whatever, podcasts, Apple Podcasts, Google Play, Google Podcasts. You can even listen to us on Spotify on your Alexa devices. That's pretty cool. So anyway, you can also obviously check us out over on our YouTube channel, which is youtube.com/MasterTheNEC. Be sure to subscribe so you get notices when we go live, because I do go live sometimes during the week with educational content, some training for exam prep, or again, of course, we have our Saturday night, 8 p.m. Central Standard Time Electrician Live show that hopefully you're listening to. So again, there's a lot of stuff we got going on, and we churn out a lot of podcasts that we share on our Electrician Live platform. So again, constantly turning out stuff for education. We don't do just once a week. We're constantly turning out material. So again, subscribe to all those platforms. You'll get access to all of it. And so if you want exclusive material, you can go over to our YouTube channel and join the channel. And you have 3 options for a monthly commitment. And you can get access to all of our 2020 material as well as we go in-depth study of the National Electrical Code for the 2020 cycle. So anyway, today's episode, we're going to talk about space about electrical equipment. So we're going to talk Article 110, Section 26. So 110.26. And again, it's part 2 of Article 100. And you probably should know that Article 100 is the requirements for electrical installations. So in 110, you get a lot of things, and a lot of people will forget that there's a lot of information in 110, your working space requirements, again, marking requirements, identification of disconnect requirements, available fault current. There's a lot of stuff in 110. But today, and I guess the one that's probably mentioned the most is 110.3b. And that is when it says a catch-all: if something is not installed in accordance with this listing and labeling, or both, then it's not installed in accordance with the installation and use specification of the manufacturer. In other words, that's what they intended to have it used for. Then you're not following it, and that's when an inspector will cite 110.3b, for example. Okay, so again, all of those are in here. Deteriorating agents, the familiar 110.14c for terminal limitations. So 114 is a pretty informative article. But on today's episode, we're going to talk about the working space, the space around electrical equipment, and kind of dig into that a little deeper. So buckle up. That's what we're going to talk about today. Now, 110.26, it says that it is space around about electrical equipment. Now, remember, we're talking 1,000 volts nominal or less. We are not talking about over 1,000 volts, okay? If you want to deal with over 1,000 volts, and you need to jump on up into Part 3. That deals with over 1,000 volts, and that is 110.26. And you'll have various working clearances there under 110.31. If that's your flavor, jump on up there. But we're going to stick with the 1,000 volts nominal or less applications. All right. 110.26. What does it say? What is it talking about? It says access and working space shall be provided. So it shall be. It's not an option. It shall be provided, and it has to be maintained about all electrical equipment to permit reach and safe operation and maintenance of such equipment. Okay, so in this, we're going to have a subdivision. We're going to have an A, we're going to have a B, we're going to have a C, and we're going to even have a D and an E that we have to worry about. In fact, we even have an F, but we're not going to talk about that today. All right, so, and I don't know how deep we're going to go into this anyway. It just depends on how the podcast works out and how long it goes, because I know people don't like my long-winded, drawn-out podcasts. I know, I hear it. I get you. All right, so let's look at the working space requirement. So as an electrician, we run into a lot of situations where we have the electrical panels and switch gear, switchboards, all these type of things, and we have to have the space to work on them. We have to have the space in front of them. We have to have the proper height. And again, all these things are dictated to us in 110.26. So we're going to kind of cover them and get a better understanding of them. Okay. All right. Let's talk 110.26a, which is dealing with working space. All right. Now, there's a big difference between 110.26a and 110.26e. The E is dealing with the dedicated equipment space. And that is literally the footprint of the switchboard, switchgear, panel board, or motor control centers. Okay. Very limited. Okay. It gives you a list of those things. So that is very limited to that dedicated space and what can go in that footprint. Whereas when we're talking about the working space, we're talking about the space from the equipment out, from the live parts out. And we're going to have a height requirement. We're going to have a width requirement. Okay. And we're going to have a depth requirement. Okay. So we're going to look at each one of those, and they're going to be basically 110.26a is going to be broken down into a sub-item 1, 2, and 3. 1 being the depth of the working space, 2 being the width of the working space, and 3 being the height of the working space. Now think of this. It basically encompasses, let's say you have a panel, electrical panel, and you put a refrigerator in front of it. Obviously, you don't want to do that because it would mean it's not readily accessible. You have to move the refrigerator. But the dimensions are kind of envisioning something like an refrigerator sitting in front of it, but it's not really there. It's an imaginary footprint of the refrigerator, so that when I'm working on the equipment, I have nothing that can impede my ability to safely get away from something, to not get pinned in an area. But I'm not encumbered that I can't work freely inside of that area. Of course, we're always going to be aware of our hands, where we place them. We learned this back in apprenticeship school or in training, our basic concepts. But again, we're working on it. We need, as electricians, this is our space. This is for us to be able to work on electrical equipment safely. And so it needs to be maintained. Now, of course, I know people pile boxes and do things after it. Probably all guilty of that. But the real reality is we can't do anything after the inspection, but we need to make sure that during the application, installation, and the job that we have to do as an electrician, that we have this adequate working space. So now we're going to kind of read what it says here, and then we'll kind of dig into the pieces of this. So it says working space. This is A. It says working space for equipment operating at 1,000 volts nominal or less to ground and likely to require examination, adjustment, servicing, or maintenance while energized. Okay, that's a key thing here. While energized, shall comply with the dimensions of 110.26A1, A2, A3, and A4. Obviously, we're going to discuss all of these. Or as required or permitted elsewhere in this code. So if somewhere else in the code will deviate from this, then it's maybe permitted somewhere else in the code. Remember, chapters 1 through 4 apply broadly throughout the NEC and all installations. However, 5, 6, and 7 can modify and supplement chapters 1 through 7 where applicable. Okay, so you might have some applications where you're going to have something, let's say for motors or something, that is going to have some different rules that might seem to contradict something that you might see here in 110.26a. So just be aware of that, and the code is saying that be aware that could come up. And it's okay as long as it's permitted elsewhere in the code and makes that permissive statement. All right, so we get the guidance. We got to follow A1, A2, A3, and A4. Okay, so again, it also gives us an informational note that says, hey, be aware that there is an issue of standards for electrical safety in the workplace, and it's an informational note, so it's not enforceable, but it is a real good document to familiarize yourself with, get a copy of it, and just have it handy. And it's all about safety, and at the end of the day, everybody wants to go home at the end of the day, right? That's the thing. We all want to be safe. So 110.26A1, which is dealing with the depth of the working space. So let's kind of dig into that first. It says, the depth of the working space in the direction of the live parts. So if you're facing the switchgear, panel board, or whatever, that is the live parts emanating out from you. So it's coming out in your face. I like to say, in your face. Okay? Shall not be less than that specified in table 110.26A1. You'll notice there's a little table. If you're in the soft mount edition of the 2020 code, it's on page 50. Okay? It'll help you out there. I always work out of the soft mount edition. I don't really do the hardbound ones for the code book, and I'm not a big fan of the spiral. Just not. Doesn't mean it's wrong. It's just I'm not a big fan of it. So anyway, all right. So we get it. So it says on table 110.26A1, which is going to give us these working space requirements. It says unless the requirements in 110.26A1A, A1B, or A1C are met. Okay. So we do have some A, B, and C applications we'll talk about. But other than that, you use the table and you follow the table. And if you have conditions where A1A, A1B, and A1C are applicable, then you get to use these applications. All right. Now, they're not exceptions. They're direct referenced here. Okay. So, and again, you meet the requirements of the table. This is the working space, unless the requirements of, again, A1A, A1B, and A1C are met. Okay. And then you get some relaxation, if you will. So there's no exception to the general rule. There's allowances within the rule to allow you to get there. Okay. So it says distances, and I'm still reading in 110.26A1, last sentence. It says distance shall be measured from the exposed live parts or from the enclosure or opening if the live parts are enclosed. So if they're open and you have live parts, that's where your measurement's going to count from. If they're enclosed and you're enclosing the live parts, then you're going to measure from the actual enclosure at the opening from those live parts, even though they're enclosed. You're going to do it from the enclosure. Okay. Long, short story, you're going to have a panel board. Let's say it's going to have a cover on it with your breakers poking through the cover. And you're going to measure, because they're not live, they're in the cover, but you're going to measure from the front of the panel board out. Okay? Just kind of keep it simple, keep it real. All right, so again, let's look at it. Now, first things first, let's look at the table before we look at any of the allowances in A, B, and C. So if you look at the table, it's a 110.26A1 working space table, and it says minimum clear distance, and it gives you nominal voltages to ground. For example, the first one is 0 to 150 volts. That's to ground. So this would be any 122 40 volt circuit. Obviously, any leg to ground is going to be 120 if we're using nominals. So this would be an example. A 12208, any of the legs to ground would be 120. So this would be, again, it's the measurement to ground. Okay, the application. Then you get up into 151 through 600, and then 601 through 1,000. So again, this is nominal voltage to ground. So with your voltmeter, you're measuring one of the legs to ground. Okay, we're not talking phase to phase. We're talking voltage to ground measurement. Okay, all right. So you'll notice there's three conditions. There's a condition 1, there's a condition 2, and there's a condition 3. Now, each one of these conditions are based on the condition description below the actual table. And so it's important that we look at this because, again, many people look at the table and they don't look at the conditions, and it would suck if you're designing a room, maybe a switchgear room or something, and you don't pay attention to what it's being made of. Maybe it's an all-concrete room, and you're not thinking about the opposite wall being conductive, and you design it. And again, we have working clearances and things like that we're gonna check all this out. But if you're not familiar with your design, man, that can screw you big time. And again, it might not be in the budget for you to be able to change this, and that would suck. So let's look at condition 1. Now, condition 1 says, and again, picture in your mind a panel board, just like maybe, let's say, the same one you'd have in your house, just to keep it simple. We're looking at a panel board, okay? And people ask, would I be actually working on that or doing maintenance or getting into that live? Well, yeah, because chances are you can't turn off the live service conductors that are coming into it because it's going from the meter into the panel. So you might be able to kill the bus, but it is live, so there are live parts. So again, you're meeting the general rules of 110.26a, so yes, this is going to apply. So then we look at the condition number 1. And the condition number 1 says, exposed live parts on one side of the working space and no live or grounded parts on the other side of the working space. Or expose live parts on both sides of the working space that are effectively guarded by insulating material. Okay, so when you say live parts, in our synopsis of this, the live parts, even though your measurement might come from, let's say, the cover, because the live parts are enclosed, you're going to treat them as live parts, okay, in that scenario. Now, if that falls under condition 1, then the 0 to 150 volts is to 3 feet, and it's probably what we're most familiar with. In fact, in number 1 condition, if I had, for example, a panel board on the backside of me was a gypsum wall, I don't know what I was trying to say, gypsum wall, then that is non-conductive, okay? It's also not grounded, okay? And there's no live parts. So I've got 3 feet to deal with, and that's fine. It's probably the most common that we see, the 3 foot. Now, this is going to apply from 0 all the way up to 1,000 volts under condition 1. All of this actual depth, okay, of working clearance from the panel's front out is going to be 3 feet, okay? All right, so the next one is condition 2. What's condition 2? Expose live parts on one side. And I remind you something. Even a panel with a cover, you're going to have to expose the live parts when you're working in it, meeting if it falls under the 110.26a and you're servicing, adjusting, maintenance, examination, whatever. You're not going to be able to shut the power all the way off. Use a little common sense. They will be live and you're going to measure, okay? All right. Anyway, just wanted to clear that up because somebody smart aleck will say, well, it's behind the cover. Dude, just stop, okay? Just stop. All right, so condition 2, expose live parts on one side of the working space and grounded parts on the other side of the working space. Concrete, brick, or tile walls shall be considered as grounded. Okay, so I could have other metal parts that have, again, equipment that have an equipment grounding conductor run to it. It'd be grounded. I have a myriad of things, but this specifically tells you even concrete, brick, or even a tile wall opposite this working space is considered conductive. And in this condition, we have some changes. Now, under 0 to 150 volts, which probably would cover our 120 to 240 volt installation, not a problem. It's still 3 feet. For condition 2. However, when it gets to 151 through 600, for example, if you had a 480-277, it's going to be 277 to ground. It falls under that condition. Then it now increases this to 3.5 feet. Okay, and then when you bump up to 601 through 1,000 volts to ground, it's going to pop up to 4 feet. Okay, so this is your working space here. Okay, this is the depth of working space that we're starting out with here. All right. Then you got condition 3. Now, condition 3, it says expose live parts on both sides of the working space. So if I had switchgear on one side, switchgear on the other side, facing each other, very common in a switchgear room. Then it says expose live parts on both sides of the working space. Column 3, if it is 0 to 150 volts to ground, it's still just 3 feet. Okay. If it's 151 volts to ground up to 600, then it is 4 feet. And 601 through 1,000, it jumps up to 5 feet. Okay? So you've got that distance between switchgear, let's say, or where the exposed live parts on both sides of the working space. Then you got that 5 feet space between them if it's 601 through 1,000. If that's the case, then you're going to have that working space here. Okay? At least 5 feet. All right, so let's kind of go back and look at A, B, and C because we have some conditions or some things that might give us some relaxation, if you will, under 110.26A1. A says dead front assemblies. It says working space shall not be required in the back or sides of assembly, such as dead front switchboards, switchgear, or motor control centers, where all the connections and all renewable or adjustable parts, such as fuses or switches, or are accessible from locations other than the back or sides. Okay, it says where rear access is required to work on non-electrical parts on the back of enclosed equipment, a minimum horizontal working space of 30 inches shall be provided. Okay? So at the end of the day, the working space, again, is not going to be required on the back or the sides of the assembly. Where you have a dead front, like switchboard, switchgear, or motor control center, that is all they list. It says where all the connections and the renewal and adjustment parts, such as fuses, switches, and all that, are accessible from locations that are other than the back or sides, obviously accessible from the front, okay? Whereas you normally would get into it, rack in, rack out, those type of things. So, again, this is just trying to not have to have it on the sides and the back. Now, if it is in the back and you have to have access to it, again, to get to non-electrical parts, for whatever reason, then you're going to have 30 inches. Okay, for that. The next one is B. And B has to do with low voltage. Now, again, controversial use of the term low voltage because, again, anything that is 2,000 and less, volts or less, is really considered low voltage. But in this context, they're going to give you voltages so you can kind of understand where they're coming from. It's low voltage. So it says by special permission. Now, interesting. When it says by special permission, that means that you need to get special permission from the AHJ. And again, special permission should be in writing, allowing you to deviate from the general rule. It says by special permission, smaller working spaces shall be permitted where all exposed live parts operate at not greater than 30 volts RMS, 42 volts peak, or 60 volts DC. This is a permissive rule. So you're going to meet the requirements for separation. Remember, the table deals with 0 to 150, okay? So you would follow the general rules unless you get special permission to have a reduction, okay? And if that's the case, by special permission, smaller working spaces shall be permitted. Now, what are those working spaces? Well, you're going to need to work closely with the AHJ, okay? They're the ones giving you the special permission to do that. And C is existing buildings. It says where existing buildings, where electrical equipment is being replaced, condition 2. Okay, so you have an existing building. There's already switchgear there. There's already equipment there. And it's already in place. And they're replacing it. It says condition 2 working clearances shall be permitted between dead front switchboards, switchgear, panel boards, and motor control centers located across the aisle from each other, where conditions of maintenance and supervision ensure that written procedures have been adopted to prohibit equipment on both sides of the aisles from being opened at the same time, and qualified persons who are authorized will service the installation. So this is allowing for a replacement in an existing building, a reduction to the clearances given in condition 2, provided you have written procedures in place so that I can't open one side while the other side is open. And again, qualified persons means you're trained, you understand the hazards involved, you have some type of training to be considered qualified. And again, you're authorized to do this, but there has to be a procedure in place. If that's the case, then again, you can reduce it down to a condition 2. An example, this might be a condition where it would require 5 feet. And under the existing building, they're going to let you reduce it down to condition 2, which might be in a 601 to 1,000 volts. It might be a difference from 5 feet down to 4 feet. That extra foot may be huge, okay, because you're stuck in an existing application. So where you can utilize C for an existing building, go for it. Again, working with the AHJ is going to be crucial so they can understand this, because not a lot of people understand C and understand the difference between the existing building. I had a guy call me one time and said, we're doing a building and I'm going to get a CO And then the next day, we're going to put in another switchgear in there, and we're going to use the first one as existing. I'm like, well, you better talk to your HJ about that, okay? Because he believed that existing building means the day after it got a CO, it was considered an existing building. Okay, I'll let y'all argue over that, and I'll let your HJ argue over that. But again, that would be a tough one to me. That tells me that whoever's designing it didn't think well, and that's an accident waiting to happen. Okay, means that they didn't take safety into consideration. And remember, who are we thinking about here? We're thinking about you, the electrician. We're thinking about you, the maintenance guy. We need our working space. I don't want to be cramped in anything. If there's an arc blast or a situation, bolted fault, something, I want to have the ability to feel like I can get out of there, move away, the ability not to feel cramped and restricted. There's a reason why we have the rules that we have. And unless you know otherwise and you submit a public comment or public input to change it, be sure to substantiate it, because this has been pretty much the rule of thumb, and I hate rule of thumbs, forever. Okay? So just things to think about. Now, it's kind of now we've established our depth. We're pretty good. Now we got to talk about the width of this working space. So we've already established the depth coming out from the equipment. Now we're going to talk about the width left to right of this equipment. And here's what the code says in 110.26a2. It says width of working space. It says the width of the working space in front of the electrical equipment shall be the width of the equipment or 30 inches, whichever is greater. In all cases, the working space shall permit at least a 90-degree opening of equipment doors or hinged panels. So in all cases, so you have to be able to open the door. It's going to have to open 90 degrees, which would be perpendicular to the front of the equipment. So you have to be able to open the doors, provided they obviously have a door or any hinged panels. Okay, so it has to be able to open it, keeping that in mind. Secondly, the width is the width of the equipment or 30 inches, whichever is greater. So a typical panel is typically going to be 14 and a quarter or somewhere around that. You're pretty close. Don't hold me to it. I can't remember. That fits between framing members, stud framing, standard framing spacing. And I think it's 16 on center. So if you cut that in half, I think it drops it down 14 something. Anyway, it goes right in the middle. The width is to be 30 inches. So in this case, the 30 inches is greater than the width of the panel board. So now here's the interesting thing. The panel board goes inside of the enclosure. The enclosure is what goes between the studs. Okay. So we talk panel board a lot and we say panel board, but the panel board is really just the guts. It's the entire assembly. Okay. The enclosure, the cabinet, everything together. So when I put that in there, I can put it anywhere in those 30 inches. I can put it to the left side of that 30 inches. I can put it to the right side of those 30 inches. I can put it slap in the middle of those 30 inches. As long as I have 30 inches that left to right for my installation. Okay? That's the trigger here. Now, how does it play when the equipment's larger than 30 inches? Okay, so we have switchgear and we have switchboards. Then they might be wider than 30 inches. Well, then it's going to be whatever the width is of the equipment. Remember, it's the width of the equipment or 30 inches, whichever is greater. Okay? So if it's greater than 30 inches, then you utilize the footprint of that piece of equipment. Okay? And again, so we have our width and we have our depth. The other question people ask me is, what if I have two panels side by side? Let's say it's a 400 amp service and there has a 380 meter and it's being fed with two separate 200 amp panels or whatever. They have two 200 amp panels, let's say, and they're side by side. Yes, the 30 inches can overlap, okay, because we're talking about working space here. So they can overlap, okay? So again, the key here is I need the 30 inches. And how we measure that is right in front of the equipment. And yes, they can overlap. I just need to make sure that I've got at least 30 inches because I know that the panel enclosure is only like 14 and a quarter or whatnot wide. You with me? So I have to go with the 30. Okay. So side by side, whatever, the working space can overlap. That's not a problem at all. Okay. I have people that think you have to move the panel board far enough away so each one has their own 30 inches. That's just not true. Okay. You can overlap them, but you got to have at least 30. All right. And interesting enough, you're probably going to have more than 30 because if you put two panels side by side, even though the 30 inches overlap, they're not going to be side by side. So you're going to get more space than you need by proxy of these rules. So again, it's going to probably handle itself. Just make sure you understand that you don't want to stick it in a cubby somewhere that's not going to give you the 30 inches. Okay. All right. So that was pretty straightforward. Moving to the next one, which is A3, which is the height of this working space. So we established the depth, we established the width, and now we're going to work on the height of this working space. Now remember, we're talking about working space. We're not talking about dedicated equipment space. Many people want to start reaching over into E, 110.26E, and we're not there yet. That's totally different. We're in the working space. Now here's what it says in A3, height of the working space. It says, the working space shall be clear and extend from the grade, floor, or a platform, okay, or platform, to a height of 6.5 feet or the height of the equipment, whichever is greater. Okay, so again, kind of like the width of the working space. We know that 6.5 feet high, unless the equipment is higher than 6.5 feet, then the working space has to continue all the way up to the height of the equipment. Okay, makes sense, doesn't it? You don't want to have to be leaning down, ducking down. We do have some exceptions we'll talk about, but we don't want to have to duck down or whatever to work or cramp in this small space. We might have the width, we might have the depth, but if you don't have the headroom, then it's just kind of hard to work on anything, and it leads to accidents. It leads to people in awkward positions, losing their balance. It's not smart, and we don't want to play those games, right? Now, as an electrician, you may be skilled, and you can contort your body into all different things, but again, when we put this in somebody's building, we don't know that we're the only ones that are going to mess with this later, right? Let's be honest. Somebody else is going to be going in there, whether it's a home inspector, homeowner, Johnny do-it-yourself, maintenance, I don't know, anybody. And so we have to think about what could happen. They aren't as skilled as you are, so we have to think about those things. Okay, it goes on to say, within the height requirements of this section, okay, it says, other equipment or support structures such as a concrete pad associated with the electrical installation and located above or below the electrical equipment shall be permitted to extend not more than 6 inches beyond the front of the electrical equipment. Okay? So this is basically giving us the allowance to say, okay, we have this height restriction, but I could have other equipment, okay, that are going to extend into or be the supporting structure, such as having this equipment sitting on a concrete pad. And we have to be aware of that's what we can do. And it says, with the electrical installation and located above or below the electrical equipment shall be permitted to extend not more than 6 inches beyond the front of the electrical equipment. So if I have a pad and I mount the switchgear on it, the pad can extend out no more than 6 inches, okay, from the equipment. But this also gives me some allowances as well, where something might extend out underneath or into the working space, and it just can't extend more than 6 inches beyond the front of the electrical equipment. Doesn't say it can't be there, but I see pictures all the time, for example, of people putting transformers directly in front of a panel. Well, obviously, we're encroaching on our working space, the depth of the working space, and all that. But again, obviously, it sticks out beyond the actual front of the equipment more than 6 inches, and that's a problem. Okay? So again, I can have support structures like the concrete pad, things like that. If it's located above or below the equipment, then it's permitted to extend not more than 6 inches beyond the front of that electrical equipment. So remember that. Nothing can penetrate or stick out from it. Now, there are 3 exceptions here to the rule in general. Exception number 1 says on battery systems mounted on open racks, the top clearance shall comply with 480.10d. Okay, so you have some rules there. I'm not going to go look at 480.10d because that's dealing with batteries and it's not really the germane. But just remember, if you have some allowances above, okay, where you have a battery system mounted on open racks and you have what's called a top clearance above it, and you want to be aware of 480.10d, okay? Now, exception number 2, probably the more common one that we see, or at least I get people call me about, that say, okay, I can't meet these rules, and I need to meet these rules, and it's a height rule, because obviously it's an exception underneath item 3. And here's what it says. It says, exception number 2, in existing dwelling units, okay, existing dwelling units, you know, they've been around a while, right? It says, service equipment or panel boards that do not exceed 200 amperes shall be permitted in spaces where the height of the working space is less than 6.5 feet. Okay, so you remember we just talked about the requirement for 6.5 feet, but it is less than 6.5 feet. Okay, if I'm dealing with an existing dwelling unit, and this is very common where we have dwelling units that might even have something down in a dry crawl space or something that might not be qualified as a basement, but it's like a basement, and they have a panel down there, they put it there, it is what it is, it's existing, and they don't meet the height requirement. Okay, there is no break on the width and depth, okay, although it probably didn't care about that in the past either, but in an existing application, when I'm dealing with that, then the height can be reduced to less than 6.5 feet. Now, here's an interesting thing. There's nothing in the code except for in mobile home applications where they make you outside has to be 2.5 feet above grade for flood issues. Anywhere else in the code, we're more or less telling you that breakers can't be higher than 6'7" to the middle of the handle tie, but we don't tell you how low it can be because, again, I've seen them right down low, a foot off the ground when you had a home that was specialized for little people. And they need to get access to it. Okay, so at the end of the day, again, boy, awkward as crap as an electrician trying to wire that up being so low. But I mean, you know, there you go. But in this case, the headroom is giving you some relaxation, but it only applies to an existing dwelling. Again, this brings somebody to come to me and say, well, what if I do a CO and then I want to come back and do it later? I'm like, first of all, you couldn't get CO for it to even be argued that's existing without it passing your current inspection. And again, they have no problem with the height of it being low. They do with it going higher because it can't be higher than 6'7" to the breaker, but to any of the breaker center points. But at the end of the day, they're going to require you to meet the general rule. So this had to be an existing dwelling at the time where these rules didn't exist or somebody didn't follow it. Okay. And it's just giving you some relaxation for that height requirement, but not the width and not the depth, okay? Make that clear. And then, of course, exception number 3, it says meters that are installed in meter sockets shall be permitted to extend beyond the other equipment. The meter socket shall be required to follow the rules of this section, okay? So the meter socket installation, everything's got to follow the normal rules, but the meter itself can extend, okay, more than 6 inches, okay? So they're allowed to extend beyond the other equipment. That's an exception to the rule. Now, the meter socket, everything else, that's just the meter portion. The meter socket has to be meet these rules, okay? We're just talking about the glass portion that sticks out, and man, you'd be surprised. I've seen some that stick out, 8 inches, 10 inches. I mean, I'm not sure why, but that's just their design. I guess they have so much technology in them now, I guess, that they have more space. I don't know. I'm just saying this is an exception for the meter itself, okay, that are installed in meter sockets. All right? So that meter socket, that meter, the guts you put in it that does the measuring, or the reading for your power usage, that can extend more than 6 inches beyond the equipment. But the meter socket has to meet all the other rules that we would have within this section. Got to meet everything else, okay? And this section being 26. So working space, clearances, and all that type of stuff, all right? All right, so that kind of covers A3. I think we have a good understanding of what we're supposed to do here when it deals with the height. So again, we're going 6.5 feet or height of equipment, whichever is greater. And we remember we do have some exceptions where applicable. Okay. Next, we're going to look at A4. Now, A4 was kind of new to us in the 2017 code, and we've embraced it now. And this came from duct heater applications in 424 that, based on where they were in a duct system, you really couldn't meet all of the requirements that you would everywhere else for the space, working space, and all this kind of stuff. And the problem with that was the inspector were put in a weird position. And the fact, if you didn't have the limited access allowance here in 110.26, they were forced to say, well, I'm going to have to look the other way because we have no limited access applications like in crawl spaces or above suspended ceilings, which in many cases is limited access. It was big enough to get the equipment in there. The openings are large enough to get the equipment in there, but I don't necessarily couldn't meet the height requirements. But I maybe could meet the width and depth requirements. So they came up and moved the most important aspects out of duct heater applications and moved it up here into 110.26A4. I think it was a good move because we do these things all the time, and sadly, the inspector has to accept it. Well, I guess they don't have to accept it. But again, common sense would dictate, look, you got the equipment in there. You can work on it. I'm going to turn the other cheek, but now they have something that they can rely on and say, yeah, this is what allows you to do this. So let's look at it. So what we're talking about is applications that might be in crawl spaces, low basements that wouldn't qualify as a basement, but it's kind of like a basement with a limited height access and things like that, or again, above a suspended or dropped ceiling application. So it says, limited access, A4. It says where equipment operating at 1,000 volts nominal or less to ground, common theme here, and likely to require examination, adjustment, servicing, or maintenance while energized is required by installation instructions or function to be located in a space with limited access. All of the following shall apply. So there's no cherry picking here. It's all of the following. There's 4 items that you have to meet in order to be able to have this limited access reduction of height. Okay? If you can meet all of them, then you can do this. If you can't meet them all, then you're pretty much screwed and the equipment couldn't go there. Okay? So at least it gives the AHJ something to be able to bargain with a little bit here. So let's look at 110.26 A41. It says, where equipment is installed above a lay-in ceiling, there shall be an opening not smaller than 22 inches by 22 inches. Okay, so most of these drop ceilings are going to be that anyway. You do have some integrated ceilings that might not. They have 12 by 12 tiles, then that would be a problem. But if you have a normal 24 by 24 or 24 by 48 opening, you're fine. So again, you have to have that access if it's above ceiling, lay-in ceiling, or drop ceiling, suspended ceiling, for those that are not familiar with what a lay-in ceiling is. It says, or in a crawl space, there shall be an accessible opening not smaller than 22 inches by 30 inches. Okay? And that kind of harmonizes a little bit with the HVAC standards and things like that for access. Okay? So above a suspended ceiling, 22 by 22, and not smaller than that. And crawl spaces, 22 by 30. I think that the other aspect of it is you have the ability to get into the equipment. Now, ironically enough, above a suspended ceiling, you're probably putting the equipment in before they put the drop in, so this is just for servicing. Whereas in a crawl space, they have to literally get the equipment in through the crawl space opening. So 22 by 30 is probably more indicative of being able to do that. So let's assume you can meet all of 1. Then you go to 2. 2 says, The width of the working space shall be the width of the equipment enclosure or a minimum of 30 inch, whichever is greater. So again, a direct cut and paste from the requirements that we have over in 110.26A2, right? Now, you will notice that it doesn't say anything yet about the door opening 90 degrees, but don't worry, it will. But we're just kind of got to meet each one of these. So we meet this, we're good to go. The width of the equipment or 30 inches, whichever is greater, we're good to go. Item number 3, it says all enclosure doors or hinges panels shall be capable of opening a minimum of 90 degrees. So here we pick up that 90 degrees to be able to open that door perpendicular to the front of the equipment. Allows easy access. Good to go. And then number 4, and here's the one that tends to confuse people, but again, it's the biggest benefit here when we're talking about the limited access. It says, the space in front of the enclosure shall comply with the depth requirements of table 110.26A. So you got to meet the same requirements that we just talked about earlier. It says the maximum height of the working space shall be the height necessary to install the equipment in the limited space. So makes sense, right? If I can get the equipment in there and install this equipment, then it obviously has enough space to be able to work in there and get it in there. Not saying it ain't going to be awkward, but again, this is allowing the installation of these things in this limited access space. And then the last one, it says a horizontal ceiling structural member or access panel shall be permitted in this space. So the space that we just established, it is okay to have some kind of horizontal structural ceiling member in there. It's not going to inhibit us. Obviously, if you can get the equipment in there, it's not in the way. So it can be in this space, this measurement here, this width and this depth. It's okay to be in there. And again, the access panels shall be permitted in this space as well. So again, the cross members, let's say, of the suspended lay-in ceiling, those type of things, it's perfectly fine. Again, those cross members can be removed as necessary. It's not that big a deal. But again, this is written in a way that's just being a little flexible. Okay. And again, inspectors need to be flexible. Again, some things just go above suspended ceiling. I'm just saying. All right. Okay. Next one we'll go into is, I'm not going to deal with item 5 because that's separation from high voltage equipment. Not what we're going to discuss today. Just read it. Again, this is talking about where you're dealing with switches, cutouts, and other equipment operating at 1,000 volts nominal or less that are installed in a vault or in an enclosure where they're exposed to live parts, exposed to wiring that might be operating at over 1,000 volts nominals. It's just reminding us that the high voltage equipment shall be effectively separated from the space occupied by the low voltage equipment by a suitable partition, fence, or screen. Well, you know what? I went on and did it anyway because that's basically exactly what the code says. So if I'm going to have a vault that's going to have low voltage and over 1,000 volts in the same location, then I have to construct a way to separate the high voltage equipment, effectively separating it with partitions, fences, or screens away from the lower voltage applications, okay, 1,000 volts or less, okay? So I have to do that. And again, if you're in that world and you're dealing with vault rooms or some large enclosures that you have this, then you know that the separation is going to be inherent. And there's a lot of equipment that does have higher voltage coming into the equipment and low voltage going out, and it is separated by partitions that are built into the equipment that is effectively going to separate or partition off the high voltage application from the lower voltage application. Okay. And a lot of big equipment, this is inherent. Okay. So you could have equipment where you have gear that actually has a transformer in it and it brings in high power and it's going to have low going out. And it's inherently designed a specific way for this separation or partition. Okay. That's a kind of an example of it. But you could have a vault that you just have the intermingling and you have to be able to have some type of separation. Okay. That's incumbent on you to make sure this takes place. All right. So then let's get to 110.26b, and that is clear spaces. Here's what it says. It says, working spaces required by this section shall not be used for storage. Okay. I don't know how many people I've run into. I go to buildings and I notice that you store everything in front of the panel. In fact, I encourage commercial buildings, and hard to do that in residential, commercial buildings to actually paint on the floor their working space, width and depth, and put wording in there that says no storage allowed in order to maintain this space. Again, electricians are creatures of habit. If somebody stored something there, we don't feel it's our, we can move it as many times, although you'd be duly right to do so. We're afraid that if we move something that if it gets broken or somebody sees it moved and something's not working later or broken, they're going to blame us. So, we're creatures of habit. So we will contort around something and move around it, not move boxes when we really should move boxes, because we don't want to disrupt the owners. We don't want to cause a problem. And we think we can do this. We get this machonism where you become the macho man. And, yes, women can be that way too. And we can do this, or I got this. I can do it. I don't need to worry about it. I can fit in there because people put this storage. Here it's telling you can't do it. It has to stay clear. Okay. I do know that I used to tell my guys, if you went to a commercial site and this was the case and you had stuff that was blocking it, then you tell them that you need to reschedule. We'll come back another day. I don't want my guys moving any equipment, any boxes. I want the owners to do it. I am not putting my guys at risk. I'm not. Okay. They all have families. They all need to get home at the end of the day. So again, it needs to be clear. Now, it goes on to say, where normally enclosed live parts are exposed for inspection or servicing, the working space, if in a passageway or general open space, shall be suitably guarded. Okay, so if it's in a corridor, hallway, and it has to be opened or exposed, then you have to have the ability to block off this passageway or general open space with suitable guards so that people won't come in contact with this space. Okay? If the panel is in that space and it could be, it's exposed to inspection or servicing in that working space, then you have to put some type of guarding or something down to actively keep people from putting stuff in that space. Okay? It's there for a reason. We're establishing all of this for a reason. So we have to maintain it. Now, I know there's some people out there say, Paul, that's easier said than done. Okay, you're preaching to the choir, and I know that I'm preaching to the choir, but it is what it is. It's what it says in the code, and we have to kind of understand it. It's there for a reason. People have been hurt because of not maintaining working space in the proper clearance. Okay? All right, the next is item C, and this is 110.26c. This is entrance to and egress from the working space. Okay, so we established this working space. We spent a lot of time doing that. We spent 53 minutes doing that. So now let's talk about entrance to and egress from the working space. Here's what it says. At a minimum requirement, it says at least one entrance of sufficient area shall be provided to give access to and egress from working space about electrical equipment. So we have to be able to get to it. Makes sense. Door opening, don't necessarily have to have a door on an opening, but this opening has to be adequate in order to be able to allow me to get to and get from the space. Okay, so I have to have the ability to get to it and be able to egress from the working space. Now that is general for all of these applications that are covered that require working space. Okay, be able to get to it, get from it. Of course, that goes hand in hand with readily accessible. If, for example, the panel boards, a switch gear, and all that has to be readily accessible to get to those overcurrent protected devices, then it has to be readily accessible so that I can get access to it without using any keys. Without any tools. A key doesn't mean that it's not readily accessible. Okay, it explains that in the definition. But I mean tools like screwdrivers, things like that, or that require us to climb over or under something to be able to get to it, then it's not going to be readily accessible. Okay, it kind of goes hand in hand with the definitions in Article 100, which you should read. We should all focus on definitions. In this case, it's just saying, you've got to give me access and you've got to give me egress from this space. Now, what happens if I have larger equipment? Well, then that kicks into C2. And so let's talk about what large equipment is. It says, for large equipment that contains overcurrent devices, switching devices, or control devices, okay, so 3 caveats here. It says, there shall be one entrance to and egress from the required workspace not less than 24 inches wide and 6.5 feet high. Notice we don't get any of that requirement in C1 for the general rule. For normal, we just have to have at least an area, sufficient area to get to it. Again, eye of the beholder, right? You with me? But when it comes to large equipment, we're not going to give you that luxury. It's got to be 24 wide and 6.5 feet high at each end of the working space. Okay? Now, it says, this requirement shall apply to either of the following conditions. Okay, so again, we've established large equipment. It's got to contain overcurrent devices, switching devices, or control devices of some type. And it says there shall be one entrance to and egress from the required working space. And we told you it's got to be 24 inches wide and 6.5 feet high. And it has to be at each end of the working space. Now, the requirement shall apply to either. So we just gave you the rules. Now we're going to tell you how they apply. Number 1, it says for equipment rated 1200 amperes or more and over 6 feet wide. Now, this is an important thing, the word and. And is very important because and is telling me that the first rule here is it has to be rated 1200 amperes or more. So we have a 1200 amp threshold. Okay, and again, remember, we're talking about the 2 entrances requirement now. Okay, it says that it has to be 1200 amps or more and over 6 feet wide. So if it was 1200 amps, but it was only 4 feet wide, then you wouldn't require the 2 entrances on either end of the equipment. You still have to have the adequate space, but you wouldn't require the entrance and egress at each end of the equipment. The and is very important to understand. Now, we have a 2 that was changed for the 2020 edition of the National Electrical Code. And let's read it, because this came up with a conflict that people had and said, well, what if I have cumulatively more than 1200 amps or 1200 amps or more, but my equipment is maybe 2 separate pieces of equipment? How do I apply this rule? So here's what it says. For a service disconnection means, again, only applies in this rule for service disconnection means, because it makes reference directly to service disconnection means. It says, for service disconnecting means installed in accordance with 230.71, and of course, you all know if you listen to our other shows or other podcasts, we've talked about 230.71 in a lot of detail. And if you go back and look at it, and I won't, but that's the maximum number of disconnects, and there's been quite a few changes in that for the 2020 NEC. Most notably, the 6 disconnect rule is altered moving forward. Of course, you can't have 6 disconnects in one single enclosure now. But again, we have another podcast, another video on that, so go listen to that. So again, this is just talking about having multiples. So it says, where I have multiples in accordance with 230.71, it's for service disconnection means, it says where the combined ampere rating is 1200 amperes or more and over 6 feet wide. Why is that important? Because now I could have a 600 amp 4 foot wide service equipment, and I could have another one that's 600 amps 4 foot wide service equipment. Cumulatively, they're 1200 amps or more, and cumulatively, the space is 6 feet or more. It would be 8 feet. So then that kicks in your requirements. Now, here's where some people get confused. Your working space, clearances, that's still existent. That didn't change. Remember, this rule is only talking about the requirement for entrances at each end of the equipment. Okay? There's still, each equipment has its own depth and width and height, and you treat them the way they are. Can these workspaces overlap? Absolutely. I mean, you get it, right? Typically, they wouldn't overlap because these are probably going to be wider than 30 inches anyway. We said it was 4 feet, so 48 inches wide. So, again, it's going to be the width of the equipment. So, I mean, they kind of rule themselves. Here, we're really sticking with the entrance to and egress from requirements for this large equipment. And that's where you should stay. Don't let the mind wander. Okay? Now, let's read on. And it also added something else in the 2020 that is quite interesting, and it caused the manufacturers to have to think about this. It says, open equipment doors shall not impede the entry to or egress from the working space. So I've got my working space. I have to maintain it at all times. If I open up the doors, and they have front doors, if those front doors being open are going to impede my ability to move freely through that workspace, whether it's to the left or to the right to get to the door on the left or get to the door on the right at each end of the equipment, then I've got a problem, okay? So the doors cannot do that. The doors cannot impede that. The best thing to do is get dead fronts that don't have doors. But if you do and they open up, then you have to take this into consideration. Why is this a big deal for a designer? Well, because we're required to have the working space in front of it. And if you open these doors in it, then it's going to impede my ability to freely move through this working space if there's an arc condition and I can get out of the space. All right. Now, with that said, you do have some allowances for a single entrance. Okay. So we do have some allowances here where you can say, well, I don't want to have the two doors. Okay. Well, then you've got a single entrance allowance here. Let me read this so that you understand it. It says, a single entrance to and egress from the required working space shall be permitted where either of the following conditions, well, it says either of the conditions in 110.26 C2A or C2B are met. So I don't have to meet both of these conditions. I meet either one or the other. Okay, and it's going to give me some ability to drop back down to only one entrance. And this is where engineers and designers are really designing the room, and they're looking at it and going, well, I can't get two doors in there at either end of the equipment based on how it's laid out, but so what do I got to do to reduce it down to one? Okay, well, let's follow it. What does A say? Well, the first one says unobstructed egress. It says where the location permits continuous an unobstructed way of egress travel, a single entrance to the working space shall be permitted. So let me paint you a picture. I've got a switchgear room. I've got the switchgear in place, and I've got a door opposite, facing the equipment. Not on the sides, but opposite. Okay. Well, if I've got the working space, and I already have my working space, I followed everything I needed to do in 110.26A. Everything's good. I've got my working space, and I can literally walk straight out of that working space right out the door with no obstruction, right out the door. If I've got a post in the middle or some kind of column in the middle, that's not unobstructed. Okay? I think you're saying, well, common sense, Paul says I can go around it. Hey, if the room is dark or something goes on or smoke filled and you see the opening and you might not, it says clearly continuous and unobstructed. Now, I'll let you and your HJ hash out a post, but I'm going to tell you, if you want to use this one, I don't want a thing in that path of egress out to get in the way. Okay? Nothing. All right, so that's an allowance there. Okay. And I don't have to do anything special because I've still got my working space, and as long as I have my working space. Now, here's where it can get kind of weird for people, is just look at B option. Now, B says extra working space. And again, we know that engineers and designers are under a lot of heavy restrictions from owners to get, again, you don't make any money in switchgear rooms. You make the money in the tenant space or the actual usage space. So the rooms are getting smaller and smaller and smaller for the poor engineers to be able to put everything in there. And, I can feel for them. But if they don't want to have the exit, or they don't have the ability based on the situation of the room to get the entrance and egress on either end of the equipment, Then they can utilize this. And here's what it says. Extra working space. It says where the depth of the working space is twice the amount required by 110.26A1, it says a single entrance shall be permitted, and it shall be located such that the distance from the equipment to the nearest edge of that entrance is not less than the minimum clear distance specified in table 110.26A1 for equipment operating at the voltage that is in that condition. Okay, so whatever the condition, the working clearance is necessary based on the condition that you're in, whether it's condition 1, condition 2, condition 3, you double that. If you double that, that means that somebody could come out of that working space and be able to get out of the room, whether the door's on the left, the door's on the right, the door's in the middle, it doesn't matter. They have to be able to move out of the working space, and then they can maneuver around to the door. The key here is the door that you're installing, the opening, has to be at least the minimum clearance distance that's listed in the table for that condition. Okay, so if you had I'm just using examples, if it was a 4-foot working clearance under condition 2 for 601 to 1000, I'm just throwing numbers here, and I increased it to 8 feet, the door itself has to be at least 4 feet from the actual nearest edge of the entrance. Okay, from the nearest edge of equipment. Okay, so that's just a design thing that you have to take into consideration. So it can be on the left of the room, the right of the room, in front of the equipment, back. If you want to go down to 1 and you want to put it on the left, and you say I can't get one on the right of the equipment, but you can't get it unobstructed straight out of the unit, or maybe you have the doors that swing open, and you're thinking, what can I do? Well, double your distance. That allows people to get out and around the working space in those doors and can get to the actual door, the single door that you're installing. Okay? Just remember, it has to be located such that the distance from the equipment to the nearest edge of the entrance is not less than that distance that's specified in 110.26A1. Okay? And it has to be for that equipment voltage and for that condition that would apply. Okay? And that would be condition 1, 2, 3, 3 foot, 4 feet, or 5 foot, or some variation in between. Okay? Pretty simple, but that allows you to drop it down to one door, but it's going to make the room bigger. And many people don't want to give up that space. So again, you might have a room though that you can't get 2 doors on. So this might be your only option. So at least it's giving you options, right? That's what we're all about. At least giving you some options. All right, now let's move on to C3, which is personnel doors. Now, the big difference for people is that we just talked about entrance and egress from the working space, the openings, okay? They can be openings. They can be open doors. They don't have to have doors on them, okay? But they're the ability to get in and out of this working space. Now we're going to talk about personnel doors, and it's a little different because the amperage thresholds are a little different. It's not the 1200 amps dealing with the entrance to and from. This is about the personnel door. And here's what it says. It says where the equipment rated at 800 amperes or more that contains overcurrent devices, switching devices, or control devices is installed, and there is a personnel door or doors intended for entrance to and egress from the working space and less than 25 feet from the nearest edge of the working space, the doors shall open in the direction of egress, and that would be moving out of the room, obviously, and be equipped with listed panic hardware or listed fire exit hardware. Now, the listed fire exit hardware is new for the 2020, which typically listed fire hardware integrates with the fire alarm system. But in the past, it wasn't listed panic hardware. They're under 2 different UL standards, so people tended to maybe not accept it, even though it was fine. But now you've got listed panic hardware, and the listed fire exit hardware is acceptable for this application. Of course, the code gives you informational note that gives you those UL standards. If you're somebody who wants to read up on those, go for it. Now, the key thing that I'll point out here is that it says where the equipment is rated 800 amperes or more. Interesting enough, We could meet the rules to have the two separate entrances at each end of the equipment. But remember that example where I said we had a 600 amp 4 foot wide and we had two of them in a room, and combined it was 1200 amps or more, and to combined it was 6 feet or more, and that triggered the two entrance and egress. Here, the personnel door requirement seems to say where the equipment is rated 800 amperes or more. It doesn't say where it combined is 800 amperes or more. So in this room, each piece of equipment is only rated 600 amps. So again, probably there's still the hazard there. Probably should have some tweaking to this rule. This would be a great place for public input in order to allow the combination application for this. But again, it is what it is. So again, the key here with the panic hardware, for those that did not know, is that you can't grab a knob. If you're in an arc blast or something like that, and you're burned or you're blinded and you kind of work your way around, you just don't want to be able to. You don't want to have to grab a handle and turn it, because you might not be able to. You're working in the equipment with your hands; it could be severely burned. You want to be able to push against it and get out of there. So that's the kind of panic hardware that allows you to get out. Again, this is a safety rule. Really not something the electrician's going to do, because this is part of the building folks thing. They're going to put the doors on it, but it's very certainly going to cause you to fail an inspection if the inspector comes and doesn't see the panic hardware. And you're going to look at them and say, I don't provide panic hardware. And they're going to say, you're preaching to who knows what choir, but you need to talk with somebody. I'm rejecting you, and I'll come back and I'll do a follow-up inspection, and we'll look for this listed panic hardware. And I would hate for your project to be stopped because of somebody else. And sadly, that happens all the time. Okay? All right. The next one we're going to look at is D, and it is 110.26D, and that is illumination. Okay? Now, it says illumination. And again, one thing to remember, we're talking about space around electrical equipment, so we're talking about illumination that's provided around this equipment. But it's very specific, and you have to read the rule to fully understand it. So we're going to do that. Here's what it says. It says, illumination shall be provided for all working spaces about service equipment, switchboards, switchgear, panel boards, or motor control centers installed indoors. Now, let me define this a little bit more. It talks about service equipment. It talks about switchboards. It doesn't say service equipment such as. It says service equipment in general. Then when it talks about switchboards, switchgear, and panel boards, they may be feeder panel boards. They may be feeder switchgear. They may be feeder switchboards. So I have people that read this and say it's only the service equipment when it comes to switchboard, switchgear, and panel board. That is not what it said. There's a comma there. It's telling you all service equipment. Obviously, we're still talking indoors right now. But it's all service equipment, and then proceeds to say for switchboards, switchgear, panel boards, and motor control centers are going to require this illumination where installed indoors. Okay? Now, it goes on to say, control by automatic means shall not be permitted to control all illumination within the working space. Now, it can control some of the automation. We have very smart buildings these days, but it cannot control all of it. Okay, so motion, we don't want it to control, and I would say use a little common sense. The general illumination that's going to be for servicing of the equipment, that's the part I would not put on automation. Although the room might be big enough where you have other parts in it that would be controlled by some type of control automatic means, like motion. We just don't want it to be an issue where you're working on the equipment and you're in it and you're not in the motion line of sight, if you will, of this automatic means, and then all of a sudden, while you're knee-deep in something, the lights go out. You with me? So again, people overthink this one and want to complicate it, but this is a common sense thing. And hopefully the engineers who designed the common sense into this concept. This is just allowing you to have a large enough room where you could have automation in there, but it can't all be controlled as such so that it all could go out. We still need to have a substantial illumination in there. And I'm just saying, use a little sense, engineers, in your design is maybe not the equipment that the illumination is designed for the actual equipment. Control whatever else you want in the rooms, fine. These sometimes can be pretty darn big rooms, but use common sense when it comes to the equipment. We want to protect our electricians and things like that are working in these spaces, okay? All right, it goes on to say additional lighting outlets shall not be required where the working space is illuminated by an adjacent light source or is permitted by 210.70A1 exception number 1 for switched receptacles. Long and the short here is that I might have a bright enough adjacent light source that would not require me to install any additional light source. And if that's the case, then I'm not required to have any additional light source outlets put in, okay? Lighting outlets. I'm fine. You're going to have to work with your AHJ on this because I do know some jurisdictions that actually will take foot candle measurements at the equipment, and it's, again, local rules, local amendments, doing what they do. They might have a requirement for a certain level of foot candles, and they might say that the adjacent source is not adequate, okay? And again, just dealing with your local AHJ, just work through those things and work that out, okay? Next one is the one that's going to be, and we'll end on this one. This is the dedicated equipment space, because this is a pretty darn important one here. And as an electrician, I like to tell people, we get little space that is ours. Obviously, the working space is ours, but other people can come into it. We want dedicated equipment space. This is about the equipment, okay? And I'll use an example that talks about a panel enclosure between framing members in a studded wall as my example to kind of illustrate this. But it is not just limited to that application. It is limited to other applications when you're dealing with, for example, switchgear, panel boards, switchboards, and that. So, look, I'm going to read it, and then I'll use my example to kind of hammer it home for those that are listening. And remember, totally different than the working space. We're now talking about the dedicated equipment space. This is where we're going to run our conduits. This is where we're going to run our cables, okay? Things like that are electrically related. It says 110.26E, dedicated equipment space. It says all switchboards, switchgear, panel boards, and motor control centers, very limited, okay? 4 things here, shall be located in dedicated space and protected from damage. Now, let me throw something at you because, again, a lot of people get confused with this. Let's talk about the disconnect outside that's for the HVAC air compressor unit, okay? Condenser, I guess just say condenser, not compressor. Air condensing unit. It is required to have working space. It is the place where they're going to take voltage readings and before they even get in to open up the equipment. It has to have the width, the depth, and it has to meet all those rules. However, it does not have to have the dedicated equipment space because it is not a switchboard, a switchgear, a panel board, or a motor control center. Okay? Important to remember that. Now, let's go on. There is an exception. The exception says control equipment that by its very nature or because of its rules of the code must be adjacent to or within sight of the operating machinery shall be permitted in those locations. But that should go without saying. So you might have something that is ancillary to the equipment, switchboard, switchgear, panel board, motor control. You might have some kind of control equipment, again, that is designed to work with it, and it needs to be near it, then obviously that's fine, okay? We understand that can go in that dedicated equipment space, okay? And it might appear to not be intimately related, but it has some kind of controlling and monitoring function. It's okay, okay? So that's why the exception's there. And this is very common for switchgear, all right? Now, 2 things here. E is broken in E1 and E2. E1 is the most commonly used, and that is the indoor applications, and that's where I'm going to use my example to kind of paint this mental picture for you. Let's read it. So we'll talk about the indoor first. It says, indoor installations shall comply with 110.26E1A through E1D. So I've got an A, B, C to D that I have to comply with. Let's look at A, the dedicated electrical space. That's my space. That's your space as an electrician. I don't want no HVAC guy in my space. I don't want no plumbing guy in my space. This is my space. It is the footprint of this equipment. Now let's read it. It says, the space equal to the width and depth of the equipment and extending from the floor to a height of 6 feet above the equipment or to the structural ceiling, which could be less than 6 feet, by the way, if it's a structural ceiling. Whichever is lower shall be dedicated to the electrical installation. No piping, duct, leak protection apparatus, or other equipment foreign to the electrical installation shall be located in this zone. Okay? Of course, we have an exception for suspended ceilings. Again, suspended ceilings aren't structural ceilings, so obviously it can be in there, and you can just imagine that it's not there and keep measuring up to the actual structural component. Okay? All right, look. This is our space. So in a panel cabinet, it's the depth and the width, and let's say it's in that wall cavity, it's from there all the way up to 6 feet or down to the floor. It's not just above it, it's below it. Nothing can go through there. Plumbing pipes can't go through there. Cooling line, heating pipe, nothing. Ductwork, nothing. This is our space. And it's very much dictated by the depth and the width of the equipment. Now, this also, as you saw, this also applies to switchgear. Again, if it's the depth and the width, and typically with switchgear, it's already on the ground, so it's 6 feet above it. Nothing else can go in there. Now, I routinely see this violated all the time. Now, does this mean that I can't have raceways, electrical raceways, and different conduits, even if it's not from that switchgear in it? Yes, because it's electrical. It falls under that umbrella of electrical. Okay? However, I would not let control wiring for HVAC go in there. I would not let plumbing, mechanical, anything like that be in this space. Okay? Now, let's get some rules here because we've got some other things here for foreign systems, and so it might give us a little bit of an allowance here, but this is just a general statement. This is my space. I don't want nothing in it. Okay? And we're talking indoor right now. All right, now, it goes on to B, and it says, okay, well, what about foreign systems? Well, it says the area above the dedicated space required by 110.26E1A. And so what do we mean? That is the space that at the 6 foot point and greater up, not within that 6 foot space. Important thing to remember here. It already reminds us that the area above that dedicated space is what we're talking about here when it comes to foreign systems. It says, shall be permitted to contain foreign systems provided protection is installed to avoid damage to the electrical equipment from condensation, leaks, or breaks in such foreign systems. So above the 6 foot point, could I have a plumbing pipe? Absolutely. Absolutely. But I'm going to have to arrange it in a way, whether it's a drip pan or some type of way, to avoid the potential for leakage or condensation or whatever to fall down into my guarded, if you will, or protected 6 foot space above the equipment. All right. So again, can I be above that 6 foot? Absolutely. Can my duct man run it through there? Absolutely. He just needs to stay out of my 6 foot above my equipment. Okay. Now, C talks about sprinkler protection. So if you have a sprinkled building, okay, very common, commercial applications, very common. It says sprinkler protection shall be permitted in the dedicated space where the piping complies with this section. Okay, so I am going to be allowed to put sprinkler protection into this dedicated space. All right, and then the concept here is, it is going to go off if there's a fire or something happens, and it's going to do its job. So it's going to permit me to have the sprinkler protection. And again, it says shall be permitted. It's not required. Talk to your HJs. They might not like something in there. Okay? So, and another big thing to remember, this is talking about in that dedicated space. This is not talking about, okay, this is not talking about the working space. Big difference, folks. Big difference. This is the dedicated equipment space. I have a lot of people that email me confused about that because they get lost in E and forget that we're talking about two separate things. Okay? And then the next one is suspended ceilings. It says a dropped, suspended, or similar ceiling that does not add strength to the building structure, and we kind of talked about that, and you kind of can forget it's there, if you will, shall not be considered a structural ceiling, so it's not going to break your measurement from the top of the equipment up to 6 feet. Okay? So your structured ceiling might be 8 feet for whatever reason, and you might have the suspended ceiling at 5 feet above the equipment. That's okay. You can forget the drop ceiling is even there. It's not structural in nature. So you're going to measure up 6 feet, forget that the drop ceiling is there, and anything above that 6 feet up to the 8 feet, that 2 foot area, I could have a foreign system in there, but I have to protect it in a way that prevents leaking and all that. So can I have sprinkler protection? Absolutely. In that space, I can have that in my 6 foot space. But if I do so, I still have to follow the rules for protecting it against possible leakage and things like that over my equipment. Okay? But remember, we're talking equipment space. We're not talking anything in our working space. Keep the two separate deals, folks. All right? Now, let's talk about outdoors, because that was indoor. Outdoor is a little different. It says outdoor installation shall comply with 110.26 E2A through E2C. So we've got A, and it's got some caveats to that, and then we've got B, and we've got C, so we're going to look at each one of them. So now we're outside of the building here. This is equipment that's on the side of the building. It says, outdoor installation shall comply with, again, E2A through E2C. A, installation requirements. Outdoor electrical equipment shall be the following. Okay? So we're going to look at each one of these in detail. All right, and number one, it says, okay, so the equipment is installed in identified enclosures. What's important about that? When we say identified enclosures, again, typically outdoors, it would be 3R, NEMA 3R, or something that's, again, rated for the condition of use. Okay? So, again, it's identified for where it's being used. Okay? It goes without saying, but that's the first caveat. Number two, it says protected from accidental contact by unauthorized personnel or by vehicle traffic. Okay, so where it's at, taking into consideration how it's installed, whether or not it needs bollards or something to protect it, need to be taken into consideration. And number three, it says protected from accidental spillage or leakage from piping systems. Okay, so typically it would also be rated for use of the environment, so not going to be that much of a problem. It's probably already rated for anything that would be in that environment anyway. So all of those pretty much take care of themselves if you get the equipment that is rated for the location to where it's being used and it's listed, identified, and labeled as such, then you shouldn't have any problem. Now, this is the next one that says, okay, so we've got that established on what can be out there. And that's pretty broad. Now we get into B, the working space. It says, the working space shall include the zones described in 110.26A. So even outdoors, A is telling us you've got depth, you've got width, and you've got height that you have to encounter, and you've got to have freedom from that. Nothing can get into that space that's going to cause you any problems of working effectively in that equipment. And then all the things that we talk about in 110.26A previously is still going to apply. Okay? Now we get into C. This is similar to what we just talked about for indoors for the dedicated equipment space, but this is very specific. And it says, the dedicated equipment space, the space equal to the width and depth of the equipment and extending from grade to at least 6 feet above the equipment shall be dedicated to the electrical installation. No piping or other equipment foreign to the electrical installation shall be located in this zone. Okay? And then, of course, an exception was added in the 2020 that said structural overhangs or roof extensions shall be permitted in this zone. Again, not going to be a problem. They're inherent to the construction. They could be in that zone. But what we're talking about is we don't want plumbing. We don't want downspouts, things like that. We don't want that in this space. Okay? So, again, very similar to the indoor. Very similar to the indoor. So, again, helping you understand the concepts of what we're trying to achieve here with this. It's all about maintaining nothing in that electrician space, okay? And that we have proper working space, we have the proper depth, we have the height, we have the benefit of limited access now in the code after 2017. So we understand now about the large equipment, we understand about personnel doors, we know about illumination, and now we know about the dedicated equipment space, whether it's indoors or an outdoor application. Well, I guess we're going to finish this up because I wasn't going to do it, but we're just going in. We're so close. Let's just do F and end this thing. F is dealing with locked electrical equipment rooms or enclosures. It says, electrical equipment rooms or enclosures housing electrical apparatus that are controlled by locks shall be considered accessible to qualified persons. Okay, so it's basically a statement that says, even if it's behind a lock of some type, maybe an electrical equipment room or a large piece of a large enclosure, it could have a lock on it. Okay, it's still considered accessible. All right, to get to the equipment. All right, by who? Qualified persons. Those are the people that need to have access to the equipment. So it's just a general statement that's giving that allowance and saying, hey, we're going to tell you what can and what can't and who can have access to it, and we want it to be the qualified person. Now, the importance of this statement is because if you remember, a lot of this equipment has to be readily accessible. So this is giving you the permission to lock it, and it's considered accessible to a qualified person. And then when you go looking at readily accessible, it says that keys, for example, if you using a key to get to the room, is still considered readily accessible by those who are qualified and who need ready access. So you could have a maintenance electrician that's part of a staff, and it's all the equipment is locked in a room, and yes, it would be still considered accessible, and it would still be considered readily accessible because the changes in the code made it clear that, for example, the use of keys does not make it non-readily accessible. Okay? So again, all these things kind of work together. It's kind of a marriage made in everyday electrical heaven, if you will. So anyway, that was kind of corny. But that's it, folks. We kind of covered 110.26 from A all the way to F. Hopefully you got something out of that. It was a long one. It was an hour and 30 minutes, so it's a little longer than normal podcast. But hopefully you got something out of it, folks. Till next time, stay safe. And God bless. And remember to follow us over on our YouTube channel. Go to youtube.com/Master the NEC. And do me a favor. Share these podcasts. Share these little presentations and little audio goodie nuggets with people you know. Appreciate it. Till next time, stay safe.